Okay, I'm going to go through the answers for the DC circuits quiz. Okay, so let's listen up. All the answers are actually here already, so I'll just be really annotating and answering them up. Okay, so based on this circuit, this is actually a series circuit. So first thing you need to take note, current is the same throughout. Okay, now this is the first thing you need to take note of. Okay, then second thing is that for series circuit, R total is actually equals to R1 plus R2 plus R3 and etc. So these are the two things to take note of for your series circuit. Now, so at the start, what we normally do is we'll fill up those that are already given to you. So this will be the first thing I'll fill up, Rx and Ry. And once I fill up Rx and Ry, because you can see the value here, 10 ohm and 40 ohm, I will go ahead to find R total. So R total is actually just a sum because of what we have indicated here, 10 plus 40. V total is the next one I'm going to write. It's really because V total is actually just the volts of the battery. Okay, so EMF of the battery or the volts of the battery is 20 volts. Now with 3 and 4, what we're going to do next is, you realize with R total and V total, you can find I total. So the fifth step I'll do is actually to find I total. Taking V total over R total, you're going to get 20 divided by 50, 0.40 ampere. Now the next step is that once you know that the current flowing out is 0.40 ampere, okay, do take note, current is the same throughout. So if 0.40 ampere is flowing through here, it means that I also have 0.40 ampere flowing through X. I also have 0.40 ampere of current flowing through Y. So what it means is that, can you see this is a single loop? So 0.40 is the one that's coming out of the battery, 0.40 ampere and coming out, flowing across the whole circuit like this. So therefore, I know Ix is 0.40, so this is number 6 step I'm going to write. And number 7 is Iy, 0.40 as well. Now, you noted that every time once you have either, in terms of the column, once you have any two of them, you can actually find the third one. So since I got Rx, I got Ix, I can find Vx. Vx equals to Rx times Ix, okay, which you're going to get 4.0. And lastly, sorry, this 8, and lastly, you can find Vy, which is this. Now, in case of you thinking, how do you get a formula? The triangle that I've been using is actually VRI. Okay, so take note of this. So this is for the series circuit, current is the same throughout. The next one I'm going to look at is a parallel circuit. So for parallel circuit, do take note, key idea here, the voltage is the same across branches. It is one of them we're going to apply. Second thing, in terms of resistance, R total actually is equals to open bracket 1 over R1 plus 1 over R2 plus dot bracket to the power minus 1. So first thing, whenever you start, since the resistance values are given to you, I'm going to write Rx, I'm going to write Ry. Once I've written Rx and Ry, I can definitely find R total. I'll apply my formula over here. Next, V total is given 20 volts again, because that's the volts of the battery. So, 20 volts. Now, next part I'm going to do is to find my I total. So to find I total, is taking V total over R total, so 20 over 8, you got 2.5. Now, so what I know is that the current coming out here is 2.5 ampere. Once the current flows to this point, you realize that it will split. Okay, how it splits, I do not know. Okay, therefore I'm actually quite stuck after this step. However, I know that the voltage across is the same across branches. So if this is 20 volts, okay, it actually means that the long terminal is 20, the short terminal is 0 volts. So we know that anywhere along this line, okay, I'm going to use a pink color, okay, and make it thicker. Anywhere along here, okay, because the current hasn't passed through any electrical component, we know that along all these pink color areas is actually 20 volts. in terms of the 0 volts, because the current coming back, wait, let me use a brighter color. Okay, the current coming back will always be 0 volts. Okay, take note, coming out will be 20, going in will be 0. So anywhere along this line here, because it won't pass through any more components, anywhere along here will all be 0 volts. Therefore, what I know is this. If I were to take a voltmeter putting here like this, okay, a voltmeter put like this, I'll know that this is 20 volts, this is 0 volts. As such, the voltmeter reading is actually 20 volts. Same thing over here, 20 volts. Over here, 0 volts. If I put a voltmeter reading, measure the potential difference, I will also have a reading of 20 volts. Therefore, Vx and Vy, okay, which I'm going to write next, is actually 20 volts. Now, once you realize that, sure, I got Rx, I got Vx, I definitely can find Ix. As long as I got 2 of the components, okay, I can find the third one. So next one I'm going to do is Ix, then after that find Iy. So it's just really using the triangle, so I know Ix equals to Vx over Rx. I'll get 2 ampere over here, and I can get 0.50 ampere. Now, if you look at it, I actually got 2 different ways of doing it. Why? Because I know at this particular point, the current is 2.5 ampere. What I calculated initially is that Ix is 2.0. That means the current flowing through here is 2.0 ampere. So as mentioned, at this particular point, current splits. Right? The current splits. So 2.5 going into this junction, 2 ampere flows to the right. How much will flow down? The answer is actually 0.50 ampere, because 2.5 minus 2.0. So there's 2 ways to do it. One is by using the formula like this. The other one is really by your understanding that the current is splitting. Okay, so this is how you go about doing this second part here. The third question, now this is no longer that simple because I got a series and parallel together. So once again, this one here, you must really think through carefully of how the thing works. So let's start with the simple one first. Rx, Ry, Rz, write in all the values. Okay, now, to find the R total, okay, so 1, 2, 3. To find R total, okay, you need to take note, this is connected to this. X is connected to Y and Z. Y and Z is in parallel. So that's why I did 1 over 20 plus 1 over 30 to the power minus 1. Because these 2 components, Y and Z, are in parallel. Therefore, I use the parallel formula. Then because Y and Z is connected in series to X, you realize I just add it in. So 10 plus this whole part here, I get 22 ohm. Okay, so this is step 4. Now V total is 40 volts. Okay, because that is the voltage of the battery. Now, once I reached here, you realize, oh, I'm a bit stuck, No, you're not stuck yet, because if you got R total, you got V total, you can definitely find I total. So taking V total over divided by R total, you actually get 1.81 ampere. So how does it look? It means that the current coming out here is 1.81 ampere. You know that the current flowing through X will also be 1.81 ampere. Therefore, my next step, I can fill up Ix. So if I know Ix is 1.81 ampere, okay, I can fill up there. And what you realize now is, sure, I got Rx, I got Ix. What can I do? I can find Vx. So this is the next step that I'll be doing, taking Rx and Ix at 18.1 volt. So what does 18.1 volt means? So let's go back to the analogy. If this, the battery, right, when they say this is 40 volts, it means that the long terminal is 40, the short terminal is 0. So anywhere along this pink color line, let's make it thicker. Anywhere along this pink color line, okay, the volts is 40. Let me erase here, put 40 volts. Okay. Anywhere along this light green line, it will be 0 volts. Okay, this is all we can decipher so far. However, what I know is that Vx is 18.1. What it means that if I were to connect a voltmeter like this, the reading here will say 18.1 volts. Which means that X has consumed 18.1 volts. So 40 minus 18.1, I will know that down here will be 21.9. volts. Okay, so I can now continue. If this is 21.9 volts, if here is 21.9 volts, it means anywhere along these lines, because it hasn't passed through any component, this is 21.9 volts, this is 21.9 volts. So therefore, I know that the voltage across Y, you can see 21.9 is 0, so this will be 21.9 volts. If I were to connect a voltmeter here, you realize the reading here also will show 21.9 volts. So that's how actually I go about finding Vx and Vy and Vz, sorry. Okay, Vy and Vz. So actually 9 is this step over here where I managed to find the 21.9. And because based on my drawing, I know that Vz is also 21.9. Now, with Ry and Vy, I can find Iy. So this is actually step 11. With Rz and Vz, you realize that you can find Iz. Okay. Now there's two ways of doing it because you also realize that the current will split over here. At this particular juncture, the current will split. So if I know one of them, I can find the other one by subtracting. So that's what this part here is for. So this is based on formula. This is based on understanding. Okay. So this is how you go about doing this question over here. Next, let's go through question 4. So this is once again another series and parallel combination. So how to go about doing this? Okay, first up, once again, let's start off with the Rx, Ry, and Rz. So 1, 2, 3. All these are given. As such, because I'm given 1, 2, 3, I can definitely find R total. So you know that X and Y are in series, so therefore you can see the 10 plus 30. But X and Y is in parallel to Z. That's why it's 1 over 10 plus 30 plus 1 over 20 to the power minus 1. Therefore, you got 13.3 ohm. Next, V total is 40 because that is the voltage of the battery. Next, what I can find, because I got R total, V total, I can always find I total. So that's 3.0 ampere. Now at this particular juncture, that's where you also get a bit stuck. You know that the current coming out here, okay, flowing here, the current is 3.0 ampere. However, you do not know how it splits. You do not know how the current splits. Therefore, you are sort of stuck. So what you can do next is to draw the lines for the voltage. So this long one is 40 volts. This short one is 0 volts. So therefore, what I know is anywhere along this pink line, because it hasn't passed through any components, this will show 40 volts. Here will show 40 volts. Anywhere along the green line, it will show 0 volts. So therefore, I know that if I put a voltmeter here, the reading here will actually be, can you see 40 and 0, the potential difference is 40 volts. Therefore, I can do the next part, which is, okay, Vz. So because of this understanding, I know Vz is 40 volts. Now, once I know Vz is 40 volts, okay, I can got Rz, Vz, I can find Iz. So therefore, step 7 is to find Iz. I know Iz is 2.0 ampere. So 3.0 ampere flowing here, I know coming down here is 2.0 ampere. So looking at this, you can see the current comes here, it will split, right? If 2.0 flows down, how much will flow up? Answer is 1.0 ampere. Therefore, I can find Ix and Iy because this region here is the current flowing through X and Y. Can you see there's only one path for the current to flow? So 1.0 ampere, how do we find? It's actually 3 minus 2. I total minus Iz. So this is step 8, this is step 9. Because I know Ix and Iy, the current is the same. Once again, look at here, this is how the current will flow. There's only one path. And hence this whole part region here, maybe I use a different color to show you. This whole region here, the current is 1.0 ampere. Okay, so once I'm done in that part, life is easy already because you got Rx, you got Ix, you can find Vx. You got Ry, you got you got Ry, you got Iy, you can find Vy. Okay, 1, 2, 3, 4, 5, 6. Oh no, this 7, 8, 9, 10. Okay, sorry, let me do this. 8, 9, 10. No, not 10 here. Oh, yeah. 10 here. 11 here. 12 here. Okay, why am I so keen on writing numbers? It's really let you see how the question, in terms of the flow, what you can be finding. But the key idea here is it's not really so much as this is the sequence that you should be finding the question, okay, in terms of answering, but really very much of the thinking through the whole question itself. Okay, the next two parts is really where you don't have a table anymore, so we need to work on it based on whatever that's given. So battery connected to 3 resistors, you realize the question looks exactly the same. They want you to find the total resistance. So can you see here, X is in series to Y and Z. Y and Z is parallel to each other. So they have 100 plus 1 over 150 plus 1 over 300. Answer is 200 ohm. So the R total is 200 ohm. I know 240, this is actually V total. So therefore, if I got V total, R total, I can actually find I total. Right? This one is actually I total. I know that you realize I total also flows through X, so I know that the relationship is I total actually is also the same as Ix. So therefore I say here Ix equals to I total, which then I can use the formula V total over R total. So 240 over 200, which we already calculated, answer is 1.2 ampere. Okay, next, find the potential difference across Y. I want to find, if you put a voltmeter like this, what would be the reading? So definitely I know one thing for sure is that, okay, based on whatever that we have done previously, okay, so we know that 240 volt means the long terminal is 240 volts, the short terminal is 0 volts. So anywhere along this line is 240. Anywhere along this line is 0. Okay, so let's label it. Okay, all the points that you are interested in. So let's use pink, let's reduce it. So at this particular point is 240 volts. Let's use green now. At this particular point is 0 volts. At this particular point is 0 volts. So key idea, if I got Ix, I got Rx, I actually can find Vx. Now, so taking Ix times Rx, which is 1.2 times 100, I actually get 120 volts. What it means is that if I were to connect a voltmeter like this, the reading of my voltmeter will be 120 volts. So it tells you that X consumes 120 volts. So 240 minus 120 at the region here is 120 volts. So now, let's continue. If this is 120 volts, you will know that anywhere along this line will show 120 volts. Down here will show 120 volts. Okay, so based on that, to find the potential difference across Y, actually is quite simple, right? Can you see? If this is 120 volts, this is 0 volts, the potential difference here will be 120. So how to go about doing the working? It's really to find Vx first. And after that, we find Vy by doing the subtraction. Okay, so actually we find this first as a first step, then we find this as a second step. Then after that, because we have found number 2, we can find number 3. So that was the sequence that we are doing in order to solve for C. Last one, calculate the current flowing through resistor Z. So resistor Z is at the bottom. I want to find the current flowing through here. What I have is actually the voltage. The voltage is actually 120 volts because down here is 120, now is 0, so I know the potential difference is 120 volts. This is Vz. This is Rz. So do you realize if you got Vz, you got Rz, you can actually find Iz. So Vz over Rz, 120 over 300, you got 0.40 ampere. Okay, now you must really walk this through step by step slowly. If you try to rush it, most people will get confused between the idea of what current is and potential difference or EMF or voltage. Now, all these once come together, you are confused, it's going to be very difficult to solve it. Okay, so please take note, solve it step by step, no rush. Last question, similar once again, 3 resistors, except the connection is a little bit different. So first thing, they asked me find for the total resistance. So simple, can you see these two is in series, X and Y are in series. So 1 over 200 plus 400, and so that's why 200 plus 400. But this is in parallel to the 800. Rx and Ry is in parallel to Z. So therefore it's 1 over 600 plus 1 over 800. You're going to get 343 ohm. Okay. Now once again, because you got R total, you got V total. So I can always find I total, which is 0.70 ampere. Now what it means is that the current flowing through here is 0.70 ampere. Flow until here, 0.70 ampere. But at this particular point, I know current will go up, current will go down. It will split. So because it will split, I can't determine what's the current flowing through the top or flowing through the bottom. Okay? However, one thing I know is this. Okay? Is that the potential difference I can find out. How do I know? Remember, this long pole is 240 volts. Okay? This short is 0 volts. So whenever you're stuck, then just do all your necessary working once again on your circuit. So I know anywhere along this pink line is 240. Anywhere along this green line is 0. So therefore, I can actually label it at this particular point. Okay, this is actually 240 volts. Here is 240 volts. Here is 0 volts. Here is 0 volts. So you realize if I put a voltmeter here across Z, the reading is 240 minus 0 is 240 volts. Therefore, I know Vz is 240. I know Rz because the value is given here 800. So I know Iz is 0.30. Right, 0.30 ampere. Now, once I know the current flowing down is 0.30 ampere, I can actually find the current flowing up. So that's where I take 0.70 minus 0.30, I'll get 0.40. So this current flowing up is 0.40 ampere. And 0.40 actually flows through X, flows through Y, okay, and come back here. So therefore the current across X, the current through X and the current through Y is actually the same, which is 0.40. Okay, lastly, is it lastly? Oh, sorry. Next one, calculate the potential difference across Y. Okay, Y is over here. So I know the current across Y is 0.40. Can you see? 0.40 across here will also be 0.40 ampere. So therefore, if down here is also 0.40 ampere, I know Iy is 0.40. I know Ry is 400. So Iy is 0.40, Ry is 400. Multiply them together, I get 160 volts. So which means that if I put a voltmeter like this will actually show 160 volts. Okay. Lastly, find the current flowing through resistor Z. Okay, actually we have found that right from the very start already. Okay, once again it's a repeat of this. So therefore it's a 0.30 ampere. Okay, so this is how you go about doing all these questions. Do take note. My advice to everyone for this is really to do it step by step. Don't rush through it. Okay, do step by step, don't rush through it. If anytime questions like question 5 and 6 you are stuck, okay, I've seen many of you, you can actually just draw this table on your own and then work it out. Okay, I think with the table you are actually a bit clearer of also how to go about doing it. Okay, so that's all. Okay, take note, revise hard.